Now we are moving along from arithmetic sequences to geometric. We have a warm-up to do today, and we would like you to do that right now. So please go ahead and find page 26 in your packet and do the warm-up right now, and we will pause the video until you get that done. Okay, now that you've completed the warm-up, notice that the difference in the consecutive values here gives you a difference of +4. So that is our common difference. So D is equal to 4. The first term is over here. It's this -6. So A of 1 is -6. So our explicit rule for this is arithmetic because we are adding a constant difference. So for the explicit rule, there's a couple different ways of doing this, but one is to use A of n equals the first term, A of 1, plus D times n minus 1, or n minus 1 times D. So the explicit rule would be A of n equaling -6 plus our common difference, which is 4, times n minus 1. You can leave it like that, or you can go ahead and simplify it and give it an answer of 4n minus 10. So that's A of n. That is the explicit rule. Explicit rule for arithmetic. For the B, recursive rule, A of 1 is equal to -6. That always has two parts to it. And then A of n is equal to A of n minus 1, which means the term before, plus our constant difference. So that is the recursive rule. Remember, that always has two parts to it. Part C, we need to find the 10th term. Well, it certainly would be easier to use this nth term formula, which is the explicit rule for the 10th term. So this would be A of 10 is -6 plus 4 times 10 minus 1. So 4 times 9 is 36. 36 minus 6 is going to give you 30. Notice that tonight's homework, which you'll have plenty of time to do in class today, is page 28, 1 to 14. Your quiz is upcoming on Thursday. I realize that several people will be out due to AP testing over the next couple of days. So if you know you're out both Tuesday and Wednesday, please pick up a review worksheet. Otherwise, we'll be completing the review worksheet on Tuesday and reviewing the answers on Wednesday, getting ready for Thursday's quiz. And Thursday's quiz is only on arithmetic and geometric sequences. Okay. This is the homework answers from last night. So please pause the video and check your answers. Okay, a geometric sequence, this is on page 26, is when, let's see if I can type this. Let's see if this lets me type. Yep, when the ratio of consecutive terms, I can't spell it, consecutive terms is constant. And again, what you're looking for here is a multiplication or division that's a constant. So between consecutive terms, you are multiplying by the same number or you are dividing by the same number. So this down below is the recursive formula for a geometric sequence. Again, I provide that when they ask for it, but I typically will use the other rule for explicit or the nth term of geometric sequence to answer most questions. But down below here, what they are asking us to do is to show or determine if we have a geometric sequence here. So what you're looking to do is to show that between our consecutive, back to the pen here, between our consecutive values here, yellow is not going to work. Between these values, we are multiplying by 3 each time. Since we're multiplying by 3, This is geometric. And we are multiplying by 3. All right. Show that the following sequence is geometric. Well, to show that, we're going to have to make a chart. We also need to find the first term and the common ratio. So we had common difference D before, now it's common ratio R. So we're going to go ahead and plug in to a table where we definitely need that first term, but we're going to plug in some other values to come up with that common ratio. And I just wiped through it with the pen. I don't know why it does that. So we're plugging in 2 to the negative 1 power. 2 to the negative 1 power, remember, is move the negative exponent to make it positive, 1/2. 2 to the negative 2 power is 1 over 2 to the second power, which is 1 over 4. 2 to the negative 3 power is 1 over 2 to the third power, which is 1 over 8. And for the fourth term, 2 to the negative 4 power is 1 over 2 to the fourth power, just 1 over 16. So you can see here that between our consecutive terms here, we are multiplying by a common ratio of 1/2 times 1/2 times 1/2. So our common ratio is 1/2, and our first term is 1/2. So a of 1, that's your first term, and your common ratio is 1/2. I would like you to pause the video now and try example 3. All right, back to the video. We are going to do what we did above, which was to plug in for several terms in here to determine the first term and then several other terms so we can find the common ratio. When we plug a 1 in here, it's 4 to the 1 power. 4 to the second power is going to be 16. 4 to the power of n of 3 is 64. And 4 to the fourth power is going to be 256. Now, you're looking for that common ratio. So between 4 and 16, we multiplied by 4. Now, these are two horrendous examples because in both cases here, it's showing the first term and the common difference is the same thing, and that does not normally happen. We just picked some bad examples here. So our ratio, I keep saying common difference, but its common ratio is 4. So we have shown that it's geometric by showing that you're multiplying by a constant. That is the first term and the common ratio. So flip in your packet over to page 27, and we are now introducing the nth term of geometric sequence right here. A of n equals a times r to the n minus 1 power. So that's what we do. That is the explicit formula for a geometric sequence. It is the one that is on your formula sheet that you got. It's a half sheet of paper. If you were absent the day I handed that out, just copy the formulas down from somebody who's around you when you have time. Okay, what it's looking for is the 9th term of a geometric sequence. So again, we're using the nth term to find an n of 9. So for n is equal to 9, we need to know what that ratio is. So to find the ratio, you're taking two consecutive terms. So you take this 9 and you take this 10, and you make the common ratio. This is much easier than what we had to do with the arithmetic. And you just put the second term over the first term, divide it. So r is 9/10. Done. So here, if we want to find the 9th term, a of 9, this is the first a, which again is your a is going to be your first term. It actually can be any term, but in this case we're going to use the first term. 10 times the ratio, which is 9/10, to the power of n minus 1. So the 9th term is 10 times 9/10 to the 8th power. Remember, in your calculator, you have to do 9/10 or 0.9 to the 8th power first, and then you're going to multiply that by 10. Okay, so I got This was earlier, so I haven't used a calculator again to check it, but like something equivalent to 4.305. If I'm not correct, that just means I made an error when I made the key originally. So check your work on that one. Recursive rule for this sequence. Recursive rule, remember, is your first term, is your first part always, and then a of n minus a of n. You've got always at a of n minus 1, which means the term before, and then when you have arithmetic, you add a constant, but when you have geometric, you just put your r out in front. That's your constant ratio. And that's the formula for the recursive of the geometric sequence. At the bottom, we are finding the 7th term of the geometric sequence. Again, if they didn't tell you it was a geometric sequence, we are multiplying by 1/2. Okay, so our common ratio is 1/2. Our first term, wow, look at that go. First term is 1. So to find the 7th term, we are a of 7 equals the term we're going to start with, which is 1, times r to the power of 7 minus 1. So it is 1 times 1/2 to the 6th power, which is 1 over 64, or whatever decimal equivalent it is. Recursive rule. A of 1 equals 1. Of a and n, a of n equals the term before, which is a of n minus 1, times the common ratio of 1/2. And that is it. What we would like you to do right now is to flip to page 28, complete 1 through 14, and that is going to get you ready. You've had all the new material then for your quiz. Your quiz is going to be on Thursday. That is on all the sequences and series that we've done since the last test. So that looks like that in your packet is page 16 through 28. And again, tomorrow we're going to have a review worksheet that you complete in class. And Wednesday we will review the answers. If you have any questions, please go see Mrs. Bullock or Mrs. Mohan, and they're more than willing to help you. And thank you for being so flexible.